Hey Theo, how are you?
Hello, Jay. I'm doing great. How are you?
I I'm great now that someone that I've spent all this time talking with. I mean, we just literally had a conversation about Python maybe yesterday, and so it's always wonderful to hear what you're coming to this audience with when it comes to Python. I know you really bust your butt on getting out information about our SDK and things like that, and you've got some getting started stuff for people today. So I'm going to pull up your presentation and let you go for it. All right?
Thanks, Jay. Okay. Yeah, can we see my screen okay? Is everything good? Can you hear me okay?
You're all good. Go for it.
Awesome. Awesome. So yeah, this is getting started with Python on Azure Cosmos DB. That's my name there. I'm a PM in Jay's team as well, Cosmos DB engineering team. So I'm guessing if you've tuned into this session, you probably know about Python, but maybe Cosmos DB is not all of that familiar to you. So just a quick rundown. Of course, Azure Cosmos DB is Microsoft's um, let's say flagship NoSQL distributed database service. It's fully managed. It's a massively scalar architecture. Of course, this is expressed in multiple SLAs across latency, throughput, availability, consistency. So these are pretty comprehensive. It's pretty reliable, and the proof in the pudding, of course, is also the applications that run on Cosmos DB, and there's just a few of them here. These are just the internal ones. Some pretty big applications there, as you can see. And last but not least, of course, OpenAI uses Cosmos DB to scale its ChatGPT service as well. So why use Python on Cosmos DB? Well, as you just saw there, it's pretty much the database of choice for scalable, globally distributed applications in Azure. Why Python SDK? Well, it simplifies development pretty much by virtue of it being Python. Your Python developers, you don't need me to tell you how easy Python is to work with and to get things started and going. And of course, as I just said, OpenAI not only uses Cosmos DB to scale its ChatGPT service, but it also uses the Python SDK as well as the Spark connector also, which I'll touch on today. So if it's good enough for OpenAI, hopefully it's good enough for you if you want to start building things with Python in Azure on Cosmos DB. What I'll touch on is just the very fundamentals, the basics of the Python SDK. I'll touch on the key features and what has recently been introduced, and also point you towards where you can find out what we're working on and when. And also, I'll give a brief intro to Python on Spark, or PySpark as it's also known, with the Cosmos DB Spark connector. All right, so the basics of Python SDK: installing, connecting to Cosmos DB accounts, and doing some CRUD operations. So let's do some demo. So I have PyCharm here. I like PyCharm because of the way it creates virtual Python environments. So I'm just going to create one here, again, completely from scratch. So we'll go to the packages here and look for Azure Cosmos package. Of course, you can do this from pip install as well, but PyCharm has got this nice little feature here where you can install. I'm going to install the latest package, and once I've done that, I'm going to go through here and create just a simple file, a Python file. And we're going to go ahead and call that main.py. And I'm going to work with GitHub Copilot. So highly recommended. I'll leave a link at the end so that you can see how to set up with that. All I'm going to do here is just add comments, and those comments are going to act as prompts. And GitHub Copilot is going to do all the coding for me here. So I'm going to say create Cosmos DB client and create database and container if not exists. And it's going to go through there. And as I tab through, it's creating the code. It's importing Cosmos client function from Azure Cosmos with exceptions. And then as I tab through again, it's going to initialize Cosmos client. It's going to give me some environment variables for my credentials. This is using key-based auth. Of course, you can use default Azure credential as well. I'm creating a client and I'm passing in those credentials, and then I'm going to use that client to call to create database if not exists on the client with the database ID that it's creating for me here. Again, I'm just tabbing through and it's writing the code for me. Same thing with container. You'll notice there it specifies partition key. I'll come on to that a little bit later, and offer throughput of 400. Cosmos DB has this concept of request units. It's a normalized metric of throughput, so you don't have to worry about things like IOPS and memory and resources and so on. It's just every request has a cost in terms of request units. Okay, so I've done everything that I asked it to do. So let me just put another comment here to say create item. And again, it's going to, it's realized that I need to create a JSON item, and it's guessed at the things that I want in there. Of course, I can update that, but that's good enough for now. And it's going to go container upsert item. Cosmos DB, of course, is a NoSQL document-oriented database. It didn't manage to guess, Copilot didn't manage to guess the actual environment variables that I have, so I have to obviously change those. But apart from that, it pretty much has written all the code for me. So well done, Copilot. Okay, so Cosmos DB is a NoSQL document-oriented database engine, so it's going to store JSON documents here. Let me just debug and run through this here. And so yeah, that's going to do this, and then we can go and view what's just been created here. It's created a database in a container in my database explorer of my Cosmos DB emulator. And by the way, the emulator is free to download. You don't need to have an Azure subscription. If you're working on a Mac, I recommend that you try out the latest emulator. It's in preview. It has a subset of the features that you find in the service, and the emulator, and the older emulator, which had some issues running on Mac, but we now have an emulator that runs on pretty much any platform. So that's what I'm using here. So let's go through here and see if we've created a database. Yeah, and we've got the test container that I wanted, and it's inserted a single document. We defined ID, name, category is complete, and description attributes. Those other attributes, underscore TS, underscore tag, underscore self, are system attributes. You can see that under select star from C, there are an ID. There's an ID for every document, and that has to be globally unique. But there's also on the right-hand side there /ID. That represents the partition key. Again, I'll come back to partitioning later. You can choose ID as the partition key, and in that case, every partition will only contain one document, the unique ID, or you can choose any of the other attributes that you selected in the document. In that case, each partition will contain n number of documents. And the idea in Cosmos DB is ideally when you're querying documents, retrieving documents from Cosmos DB, you want to scope the queries to a partition. And I'll explain why that is in a minute, but for now, just keep that in your mind. Let's just go into the unknown here and just try something else. And I think, yeah, Copilot is guessing what I want to do already without even me having to type it out. It's going to create some query text here, and it's going to go to container query items function. It's going to pass in the query text. You see enable cross-partition query here. That's because select star from C, where C.category equals general, is not specifying the partition key. So that's going to be what we call a cross-partition query. Again, I'll explain why that's significant. I'm going to delete the database here so I can run the whole thing again, and it can do the upsert and then execute the query. So let's debug through this one. Yeah, we do the upsert again, and we're selecting from all of those documents. Of course, there's only one document. If there were thousands or millions or even billions, of course, we wouldn't want to do this. It would be highly inefficient. So I'm going to just run this through, and we can see, yeah, brought back that single document. But what if there's many documents? I want to just read the item by its ID. So I'm just going to put in read item here. And what does Copilot do? Let's see. Yeah, so it's done something maybe a little bit unexpected. It's going container read item. Now you might think, why don't I just do select star from C, where C.id equals item one? And actually, you could do that, and that would work fine. Except here we run into a slight nuance about Cosmos DB, which was that Cosmos DB actually has two different ways of retrieving information. It has a query engine, which has everything that you'd expect, including generating a query plan. And so if you use the query engine, it will generate the query plan and execute on that. But what you really want to do, if you're just executing, if you're just wanting to read the document by its ID and partition key, is just use what we call point reads. And in this case, it's just read item in the Python SDK. And in that case, the system is going to look for the document by the hash value of its ID and partition key, and it's much more efficient. And so why is this important? Well, like I said, and I've already alluded to it, Cosmos DB is a massively horizontally scalable distributed database. When you put data into Cosmos DB over time, as that data grows, it will be distributed onto different physical machines, and we need some way of retrieving that data from those machines or from that one machine. So it follows from that, ideally, when you're choosing a partition key, you want to be able to choose a key that allows you to scope most, if not all, your queries from that partition key. So if you're choosing ID as the partition key, ideally you only ever want to be retrieving, or most of the time you want to be retrieving just single IDs. If you need to be executing queries that are broader in scope, then you want a partition key that has a wider scope and that would be storing a larger number of documents. I don't have time to go through all the nuances of partitioning. I'll just point you towards some very comprehensive documentation that we have that goes through various different strategies, like materialized view patterns, like hierarchical partition keys, and other ways that you can be flexible, and advice on how to choose the right partition key. Definitely, it's the most important thing to learn about if you're new to Cosmos DB and first working with it, is how to do partitioning properly, especially if you're not familiar with sharding, as it's also known, or partitioning. This is definitely a good first place to go to internalize that. So in terms of docs, again, we wouldn't have time to go through everything, but I'll just point you through to this one doc, which it's a big, long doc, and it has lots of different samples for Python SDK. And if you want to see where those samples were generated, why not go through to the repo, Azure SDK for Python, go through there and find the SDK folder, and then you can look for the Cosmos folder, and you'll see Azure Cosmos, and that's where the code is for the Python SDK. And you can see under there's a samples folder, and there's a bunch of samples that pretty much illustrates everything that you can do on the SDK. And if you want to find out exactly what you're working from, what we are working on, on the Python SDK, I encourage you to go and look again at the Azure SDK for Python. There's a projects folder, and we have a public project with a public roadmap. So you can go to the roadmap tab, and you can find out exactly what we're working on and what the timelines are. We update this regularly. So if there's a feature that you're looking for, you think that the Python SDK doesn't do something that you need, have a look there, see if we're already working on it, and maybe go on there and give it a comment or something, or a thumbs up, and saying that you're waiting for this feature. And if it's not on there, feel free to raise an issue or a feature request, and we'll triage that and get to it eventually. So in terms of recent updates to the Python SDK, most recently, we released a bunch of features related to vector search and full text search, full text ranking, and hybrid search. And of course, these features also need special handling in the Python SDK. So that is the most recent update that we've done. And we recently announced this at the Ignite conference, which is a few weeks ago, which we used a demo app, which you can go and download if you want to. And this is a nice little Streamlit app, which you can go in there. And it has all the code that you need, including vector indexes, vector policy, and then the code to actually interact with these search features. And it's a simple little app. You just start it up. Let's go and have a look at this here. And then, you can just select the indexes, and then you can type in some text, and you can compare the different queries that it will run, and it will show the query that's been run and the results and so on. And so you can investigate that. And last but not least, we have an awesome samples gallery, which has a ton of samples in many different languages, but you can filter by Python, and we have a ton of Python samples as well, from everything from analytics to architecture, generative AI, data migration, different tools. And there you go. You've got a nice little RAG chatbot notebook that you can run through there as well. So pretty comprehensive in terms of samples for Python SDK. So that's everything that I probably have time for Python SDK. Hopefully that gives you some pointers. I'm going to just touch on Python on Spark, or PySpark as it's also known. Spark is a very powerful framework, which is really good for large-scale data processing, particularly for batch ingestion and streaming at very high volumes. Of course, you can do this in raw Python as well, but Python has its own limitations when it comes to scale, particularly around concurrency and parallelism and so on. But the great thing is that Spark, amongst the programming interpreters that sit on top of Spark, is Python. So you can write Python code with Spark, and we have a pretty robust Spark connector for Cosmos DB. This is a high-level overview of how it works, which pretty much reflects how Spark works generally. When you're working with Spark, when you're inserting data into the Spark environment, that data will be broken into different chunks. Each of those chunks can be processed in parallel and in a combination of memory and disk, with memory spilling over into disk, and all of this is seamless and transparent from the user point of view, as long as what you're doing is stateless and associative. Pretty much anything that you do can be done in parallel, and it's pretty high performance. There's a bunch of stuff here explaining how the Cosmos connector works. I won't go through everything, but I'll just mention here this link on optimization of Spark ingestion. If you are intending to do that with Spark, or you think that would be useful, definitely check out that that documentation for how to do that properly. There's a kind of anatomy of how an ingest notebook will look typically in PySpark. You'll have some credentials that you need to pass in. We recommend secrets, of course, or some other way of obfuscating those credentials. And then you'll have a config that you would pass in. You'll need to activate the catalog API, and then from which you can execute operations like streaming and like ingesting and creating resources and so on. I'm not going to go through all of the different configs, but I will call out just one, which is the throughput control, which is a very useful feature in the Spark connector. It helps you isolate performance when running jobs. Typically, jobs that are run in Spark tend to be very big with large data sets. And of course, you're running against Cosmos DB, which is an operational data store. So you want to protect your steady state workloads from having all of the throughput that's available consumed. So this is a way of controlling that on the client side. With rate limiting on the request units that you have provisioned, you can specify your own limit, and then that helps. There's a document there that I highly recommend that you read if you're going to use the Spark connector and you're going to do transformations on large data sets. Similarly, for streaming, there's an anatomy here. The one feature that I would call out here is that it has built-in checkpointing. One of the challenges with streaming in any framework or connector is that usually you don't have an easy way of being able to recover when there's an outage or when your job dies or something like that. From what you last processed, and particularly in Cosmos DB, where we're using a feature called change feed, which is a distributed change log of all the changes that happen across the Cosmos DB container that you're working with. If you're using the other mechanisms for reading a change feed, like change feed processor and various other things, it can be difficult to recover when there's an outage or when there's a problem. But the Spark connector does have a built-in checkpointing. So if the job dies or if there's an outage, as long as you can still access the checkpoint location in the file, you can then recover from that bookmark and start processing from where the job left off when it crashed. So yeah, there's target config and there's read stream and write stream operations here. Again, I won't go through everything, but just one pointer, little gotcha is there's a start from parameter in the config that you can use, which has values of either beginning, now, or some specific dates. You can process all of the changes that have ever occurred on a container if you say begin from the beginning or from a specific date. And if you do it from now, then obviously we'll start processing from now. The thing to call out here is all of these are ignored if there are actual bookmarks in a checkpoint location that you've defined. This sometimes catches customers out if they've used the checkpoint and then forgot about it, and then they wanted to define a specific time and it doesn't seem to work as they expect. There's two change feed modes, latest version and all versions and deletes. The names are pretty self-explanatory. Latest version is just the latest version within a given polling window and no deletes. All versions and deletes, you're going to get every version of the document. So you should only choose that if you really need every version of the document and you need to process deletes. For most customers, latest version is usually fine. And then one of the gotcha account per trigger hint. If you are processing everything in a streaming fashion, including all of the updates from the beginning, and it's a large container with a large amount of data, then beware that it's going to try and process everything in the container in the first micro batch if you don't set a value here. So you probably want to set that to a low value, and then it will auto optimize after that to find the ideal micro batch amount for each micro batch in the structured streaming that is done. Okay, so I'm going to do a little demo here. This is going to be using a hierarchical partitioning sample. I probably don't have time to describe everything about hierarchical partitioning, but except just to say that it's a way of being a little bit more flexible. And with one thing in particular, which is that if you're choosing a partition key in Cosmos DB, that logical partitioning, as we call it, will have a certain storage limit. So if you want to be able to store, you want to be able to have the advantages of being able to filter on a partition key, but you need to be able to store more data than the 20 GB limit. One way of getting around that is to use hierarchical partitioning. All of the child keys and documents under the parent key will be co-located as much as possible with the parent key, but there's no storage limit there. And so even if they exceed the physical limit of the partition, they'll be in different partitions, but they'll be co-located as much as possible. And if they don't exceed the limit, then they will be effectively co-located in the same partition, even though technically it is a cross-partition query. So that's one way around getting one way of getting around both the performance issues that you can sometimes get of cross-partition queries, but also the storage limit of regular partitioning, as it were. So let's go ahead. I'm using Databricks. Databricks is an easy, very easy way, a PaaS service for provisioning Spark clusters. It's very easy to do. You just go to compute and you can create compute. Very straightforward. There's some default settings here. I've already done this here. You do need to install the Cosmos DB connector. This is already pre-installed in things like Synapse Spark pools. But it's pretty easy to install. You just go through there, go to Maven, and then you put the Maven coordinates and then install. I've already done this, so I've just taken one of the samples. It's also pretty easy to import a file or a notebook from somewhere else in here. So I'm just going to go and show how to do that right here. We have a samples repo. Here, in fact, this is the repo for Java SDK where the Spark connector is hosted. And I'm going to go ahead and just show how to import a sample. So let me go to this Python PySpark notebook here and just go to the raw rendering of this and then get the URL. And then we can just copy that and import it in here. And that will import it into my workspace. And so that's pretty easy. But I've already imported this earlier, so I'm going to go switch to another workspace here where I edited it a little bit just to make it a little bit more realistic in terms of data volumes and also to obfuscate my credentials here. So let's go ahead and run this. We're going to use this count in Azure. So I've run the credentials cell, and then I'm going to run the cell that sets up, like we said before, the configs and the catalog API. And then I'm going to run a cell that creates my database and container. And it's also going to create a data frame and randomly generate roughly 350,000 records. So let's go through to my account in Azure Cosmos DB portal and see, yeah, it's created a container with 10,000 RUs. And let's just do a query, select count, see how many records there are in there. And we've got roughly 350,000. So if we go back to this PySpark notebook here and go to my next cell, I'm going to first run a cell that just naively tries to filter on the parent key of the hierarchical partitioning. This is less efficient because it doesn't use a range filter, so it pretty much defeats the purpose of using hierarchical partitioning, but we'll see how long that takes to execute when filtering through this amount of records. So that is going to be just over 12 seconds there. But then we're going to execute this again. And this time we're going to use a UDF that's built into the Spark connector that can use feed ranges in order to select just the parent key values, and that's much more efficient. So you can see the advantage of this. But what I really wanted to show is now that I've wrangled my data using the power of Spark and I've got a data frame that I want to work with, of course, I can convert this Spark data frame to a Pandas data frame. It's interoperable, and so this opens you up to all the nice stuff that you can do in Python that you probably are much more used to with things like matplotlib and other packages working with and analyzing data in Python. All right, so that was a whistle-stop tour of using Python with the Cosmos DB SDK and the Spark connector. Some key docs here. I already mentioned that the Python SDK docs, and also there's a tutorial there for diving into PySpark with the Cosmos DB Spark connector, and there's a link for our community stuff as well. Also, some other very useful links: how to set up Copilot with Python, which you saw me doing at the start. The demo app for all of the latest Gen AI related search features that we've released, our docs, the very important data modeling, and even more important partitioning documentation, which you should definitely review if you're working with Cosmos DB for the first time. The awesome gallery with all of our samples, and of course throughput control. If you're going to work with the Spark connector, you definitely want to check that out.
Yeah,
That's everything that I had. How did I do for time, Jay?
You have exactly 3 minutes left, and that is perfect. We have a couple of questions, and
Awesome.
they come from a really, really wonderful person in Pamela Fox. I answered this, but I'm going to let you answer it as well. If your container is small enough, all your logical partitions may theoretically be on the same physical partition, correct?
That is correct. Yes, logical partitions aren't one-to-one with physical. You can have many logical partitions on the same physical partition. And in fact, for small apps, what I was talking about with the cross-partition queries isn't really a concern. It's only when you start getting to, I would say, more than 100 gigabytes of data where you're spreading across 3, 4, 5, maybe 6 physical partitions, then it can start to be a performance bottleneck. But for sizes of up to 20 GB, or less, then it's going to be fitting on one physical partition. Yeah.
Great. Another question. Does the full text search use BM25 or a similar algorithm?
That's a good question, and I don't know the answer. But James Codila, who is presenting later on building scalable Gen AI applications, will certainly have the answer to that question.
I love that transition, Theo, because I was going to say, and if you haven't heard what you need to hear today, you're going to be able to hear a little bit more advanced stuff with James's talk. And then we've got one more. What are the usual use cases for Spark with Cosmos DB? Is it analytics processing, IoT sensor data?
Yeah, I mean, it is heavily used for machine learning training, I'm told, but I have to say most of the use cases that we've seen with Cosmos DB is really for large data movements. So if you need to move data from one container to another, let's say, or you need to move data from Cosmos DB to an analytics data lake, let's say, and you need to do transformations in between, perhaps, as well. We're seeing a lot of that kind of usage, and also streaming scenarios as well, and streaming at scale, and then doing transformations and projections while you're doing that as well. So we do see a lot of that, and we do see quite a lot of people using PySpark as well. I think because Python is so popular in the analytics space, and because Spark is so popular with doing analytics at scale, this is a pretty popular thing. So I just wanted to call it out that this is something that you can do with Cosmos DB pretty easily.
Fantastic. And so I know that we're short on time. I want to give one more question because I think it's really interesting. Douglas asks, this may be off topic, but he noticed that you're using the Cosmos emulator, and he normally develops in WSL. And I was curious, or he's curious if you can connect to the emulator from WSL.
Can you connect to the emulator from WSL? You should be able to connect to the latest emulator from there. I know we've had some problems with the old emulator. But if you can't, then I would definitely ask you to go to the repo for that emulator. I don't know if I even shared that in the. I think I did share that in somewhere in the slides. So yeah, go to the repo, raise an issue if you can't do it, because we definitely want to fix that, because we're spending a bunch of time improving that. It's in preview, and we want that to be awesome for developers.
Fantastic. Well, Theo, I wanted to say thank you so much to you. I'm very lucky. I get to hear a lot about this stuff from you directly all the time, but to be able to share that with everybody on this stream is really, really helpful. So thank you so much, Theo, and look forward to hearing more from you in the future.
Awesome. Thanks, Jay.